And welcome back. I was asked to do a little bit more with 2D arrays, so here we go. This kind of models one of the homework questions about how to find a spot in an array to put something in. But I just wanted to show you some really cool stuff real quick. So here we go to have some fun. I've got two functions prepped and ready to run, even though the assignment didn't require functions. I've got a load and a print grid. And being the lazy programmer that I am, I'm not going to do load grid first because that's the slightly harder one. I'm going to do the print grid one. So to print a grid is really kind of simple. You should have that almost in your fingertips now. We obviously have a character array at this point in time. We'll call it the grid. Actually, I'll call it grid. And we have a constant int, which is going to be the number of rows that come into it. And we have column available as a global constant because we need it for two-dimensional arrays. So here we go. So we get this character grid. Well, to make sure that we print a grid, what do we have to do? Well, it's nested for loops. So you can kind of do a little for thing, and then do another little for thing. And that kind of lays out the concept of what you're trying to do. You're dealing with 2D grids. You'd have to deal with all of it for printing it. So therefore, this is how we're going to lay out our structure to go for printing all of this stuff. So we're going to print for every row, starting at 0, because all of our grids start at 0. For that less than the size of the number of rows, and increment it by 1. And then we need to do it for the columns. For the columns less than column. And then my chocolate C++. So now I've got my nested set of for loops, one of which will handle the rows, one of which will handle the columns. And I know that after I iterate through a set of columns, I have to put a new line at the end, which means that has to go right here. And there we go with that. So that prints rows and columns. And then all I have to do is print the actual grid part that I've got. So I need a standard cout. If I put both of those colons there. Grid RC. And then if we want to make this look kind of pretty, well, actually we don't have to because these are characters. They can go side by side. So there we go. Standard cout the grid. Loop, loop, loop. Now I've finished one whole function. See, that was easy. But now to load my grid, I'm going to do something kind of fun with this grid. I believe the assignment just had you using like dashes. But let's actually build a grid. Well, how do we do that? Well, our ASCII table has all these extended ASCII codes. Please note, I'm going to write this. We'll see how it runs. It doesn't work very well on a Mac or in Linux because these codes don't exactly print cleanly. On a Windows machine, this works perfectly, which is what this class is based on. But I'll show you how to do it for a Windows machine. Give it a shot. Type it in and see how it works on your Windows box. If it doesn't work, well, such is life. In terms of the Linux and the C++ side for Macs. Well, we have these characters sitting out here. So if I want to use some of these characters for things like walls, for vertical walls, or for horizontal tops and bottoms, I can pick the characters up and note what does this. So I can come back over here, and in my little load grid function, I'm just going to make some notes. Actually, I'll do even better. I'll do constant characters. Constant char wall equals, and what was it? It was the vertical wall is 186. So I'll put vwall. Vwall is 186. It may complain about trying to convert that to a character. You should static cast that thing. Constant char hwall. And a horizontal wall, aka a roof or a floor, is 205. And then I have a constant character upper left. I'm going to get a constant character upper right. I'm going to get a constant character lower left. And a constant character lower right. And now to go find those guys. So the upper left-hand corner is going to be that, which is 201. That's the upper left-hand side. And you'll see right above it is 200, which is the lower left-hand side. So there's the lower left. And then we need to go find the other guys. Where are the other guys? Scrolling around the page. There they are, 187 for the upper right and 188 for the lower right. Okay. And then we'll be just nice, and we'll say constant car field. And we'll make the field equal to something like a little dot. Do we have a little dot? We have a little dot. We'll try 250. I'm not sure where these dots are going to print out, but we'll just go ahead and stick it in there. 250. All right. So now we've got the things we need to load into this. Well, stunningly enough, our load is going to be very, very similar to our print, and we've already written all of that. So we're just going to copy and paste that iteration set. Now, we know that we need R now. We know that we need grid, and that takes care of that. So we've got our R and C in there to handle this. We know we don't need to print this, so we'll take out the printing lines. We just know that we need to start setting some things inside here. Well, if you think about the way a grid prints out, if you kind of just visualize a grid on the screen, you'll think that, okay, I know that the column that I need to put the vertical in is basically what is going to be column 0. I know that for the size of my grid, the last column is the column -1. So I need to put a little test in here. So I can say if C equals 0 or C equals column -1. So I now know that for every row that I have where column is 0 or column is equal to the column -1, so it's either the first or the last, I want to set this grid has to be equal to the vertical wall, 186. So actually, B wall, there we go. So that takes care of the vertical size. I can test also, I can say if my R equals 0 or my R equals R -1, so the first or last row, I know that my grid is going to be my horizontal wall. So there we go. So this will, as it loops through, it'll test or my vertical set or my horizontal set. When it gets done with this for loop set, I have to go back and fix these guys right here, except for one last thing. I want to say if it's not these guys, so if, else, the grid is going to be equal to the field. So that'll set the verticals, the horizontals, and then everybody else. And that takes care of setting all those guys. The problem you run into is that without setting up a whole lot of special cases inside here, the upper corners become problematic because now you got to say if it's C is 0 and R is 0, then do this, and you have to do that before you do everything else. My personal choice is to come to the end of the for loop and just write in 4 of these things, because I know instantly that for row 0, for column 0, I need the upper left. There we go. So I also know that for my row equal to 0 and this equal to column -1, I need upper right for my row. So that takes care of row 0, column 0 and 1. For my row R -1 to 0, I know that is my last row, first column. I need my lower left for r minus 1, c minus 1. It's going to be my lower right. So that gives me a base grid to run this on. So in theory, if I did this right, and we'll see how it prints out down here in the little screen that we get, this loading the grid should load the grid with a basic playing field, and then printing the grid should actually get it to print. Shall we see if it even compiles? Oh no, bummer. Oh, it's in doing all those implicit conversion warnings. Alrighty, so we will come back here and we'll do this. Static cast to a character. And we'll come back here and copy, and we'll do a lot of pasta. And we'll close up all of our braces, our parentheses. That should solve that problem. Let's see. Yep, we build finished. Let's run it. Yeah, that's what I was afraid of. You get a really ugly kind of thing because of the way this works inside the Mac. So give it a shot. This gives you a basic grid setup. And if you want to put something special somewhere, then here's the concept behind that. And like I said, ignore the funny symbols. Just run it on something that doesn't have Unicode as a basis for it. We can put in a void and place character. And we're going to pass in the grid, of course. We need to know the size. And we need to know an XY coordinate. So this is a actual just placement here. So what will we do? Well, we'll come back down here before we print the grid in its ugly, ugly form. And in reality, we'd probably want to set this up as well, let's do that, shall we? Why not? We'll get a location. This is going to be a longer video than normal. So there's our get location. Let's go ahead and copy these guys down. So we'll start with get location. So we're going to do an int x and a y. And we're going to ask some questions of the user. And we'll just duplicate that. Actually, we'll just do the standard. X. Duplicate. Save a little time. What is the column? You want Ute. Your Y. And that will go and get us the position, so we can do get location back up here in main. Now we need to give it an x and y, so we have to create a couple variables. And that will give us our two get locations. And now we have to do the place part. Well, the place part is kind of interesting, not very hard. So we're going to pass in the grid. Pass in the R for the size. We're going to pass in a location and a location. And once again, note the difference. We had to pass by reference here because we need you to change these. We need two different things coming back. Here we're just giving it to the function to use. And then we're just going to say in here, grid x, y equals, and we're going to use the hunter symbol that we had before, like that. Now, as it talked about, here's the problem you run into. This location, if users give you locations, they natively count by 1, 2, 3, as opposed to how we count in a grid, which is by 0, 1, 2, 3. We zero base everything. So where should we actually change that? Well, my instinct is to say you can do it in either place you want. You can do it even back up in main if you want to. But I would actually come in here and say, let these be user coordinates for now, and just come in and say x minus 1 and y minus 1. As a secondary note, you should also note that the get location does no validation of where this is. If they give you something out of the bounds of your grid, it's going to fail. So in here, you should probably have some sort of loop and modify your function to pass in the boundary of the rows and say, hey, I need a row between 1 and 10, which would work out fine. And if they exceed the boundaries of the size, then you would loop until you got a correct value for your x and your y coordinates. And that will fix that piece right there. And I think if we come back up here to main, we say get location, we say place character with the grid and row and x and y. That gives us a little bit of what's going on there. Let's see, will it build? Hey, build. We'll run it. Where do you want it? So I'll do 2, spelled column wrong. And in theory, there's our H. Row 2, column 2. So you can see at least the H worked. So that just gives you an idea of how to do this stuff, how to manipulate things, and how to place things in a grid, all using functions, which we should all be using by now. Hope you're having a great day.